Hi, I'm an old guy and I do maths. Today we're looking at exponential growth with reference to a particular problem. Now, there are a number of ways in which the formula, if you like, for exponential growth can be written. I've chosen today to write it in this form, which those of you who have a finance background will recognize. It's basically a contraction of this formula here, which is for compound growth of interest. Mathematically, there's no difference between this and the formulas that you see in physics or chemistry or anywhere else for a form of exponential growth. I'm just using this because this is the one that I'm familiar with. Okay, so a couple of explanations. So I've crowded the page a little bit and I apologize. A, which is our outcome, is equal to P, which is the principal or the initial value that we start with, principal in terms of money, initial value in terms of other things, times R to the N. Now R is this expression here, which you see in the bracket here. So capital R here is basically an abbreviation for this. And where R is greater than 1, you see exponential growth. When R is less than 1, you have decay. And N is the number of periods, number of years, months, whatever, that you're interested in. Okay, so let's have a look at our problem. So a population of 1,000 grows at a rate of 3% per annum. How long before the population reaches 1,250? Now the setup here is what's important. So let's get this set up, and I'm going to use this formula, but I will work out R from this. Okay, right. So A is our outcome. Now 1,250 is actually our outcome. 1,250, and that is equal to our initial value, which is 1,000, times 1 plus our rate, which is 3% over 100. And what we're looking for is that. So we can abbreviate this slightly to 1,250 equals 1,000 times 1.03. Now that is capital R to the N. N is what we're looking for. Okay. So our problem is that we're dealing with an exponential. And long story short, in order to solve this, we're going to need logarithms or a calculator that does all the work for you. But that's not the point of this channel. The point of this channel is to show you how to do this, how to do the work without, basically, for the most part, without the calculator. We will use a calculator in the end, but we're going to set this up properly. Okay, so our next move is to get N as isolated as we can. So 1,250 over 1,000 is equal to 1.03 to the N. Now, 1,250 divided by 1,000 is probably 1.25. Just confirm that, yes. So 1.25, that's this side of the equation tidied up. Can't do anything more with this. Now, what we're going to do in order to solve this is we're going to take the log of both sides. So, fresh sheet of paper, 1.25 equals 1.03 to the N. Okay, so what will we use? We'll use natural logarithms today. I'm in the mood. 1.25 is equal to the natural log of 1.03 to the n. Now, we can do something with this. We can rewrite this as n times ln 1.03. We can move this exponential down here, and we can make this into a simple multiplication. So if we tidy this up, just so that we can put it in a form that is easy to work with, we can isolate this. Watch. Natural log of 1.25 over 1.03. Natural log thereof. Okay, now you can get out the calculator. And let's see what this is equal to. So, natural log 1.25, and we're going to divide that by 1.03. What do we get? We get 7.5491, we'll say. Okay, that's that there. Okay, now let's put this to the test. So what we're going to do is we're going to take the initial population, which is 1,000. We're going to multiply it by 1.03 to the power of 7.5491, which is the number of years in theory that this will take to reach 1250. And we should get a number, even with the rounding, we should get a number that's very, very close to what we're looking for. So there's all my working set up. This is a leap of faith. I'm going to push go. What do we get? 1249.998. I will take that as 1250. Just let me get that into frame. I'm sorry. So what I did was 1,000 times 1.03 raised to this power, which is the n that we were looking for, and that gave me very, very close to 1250. I hope this was useful. Now, this can be used in all sorts of situations where you've got exponential growth. Don't think that it's limited just to something like population or to money or any such thing. Exponential growth is what this is about. Thanks very much for watching anyway. See you next time.